So I hope you guys are excited, because I'm very excited, because I'm going to talk about Heron's formula. It is one of my favorite bird-themed formulas in all of geometry. I'm just kidding, it's not bird-themed, but I'm not kidding when I say it's one of my favorites. I love this formula. It's a way to find the area of a triangle if all you know are the three side lengths. Oops, accidentally bumped into my tripod. But if we know all three side lengths, we can find the area of the triangle using this formula. So Heron's formula. We start out with a triangle. Triangle. And all we would know about this triangle are the three side lengths. We're going to be deriving the formula, so the three side lengths are going to be variables. And I'm just going to use A, B, and C. Traditionally, that's what we have. So A, B, C. I put B there because now it makes sense to use that as our base. So the area of the triangle is 1/2 base times height. But we don't know the height. That's the problem that we have here. We don't know the height. All we know is B, and we don't know H. The only thing we can figure out about this triangle with what we have is the perimeter. The perimeter is A plus B plus C. We're going to come back to that. That'll be useful later. But for right now, if we wanted to find out H and we knew A, B, and C, we'd have to use either trigonometry, which we don't have any angles, so that's not going to be helpful, or work with the right triangles a different way. Well, we have these two right triangles, and the two sides of these right triangles, they make up B. So if I called that x, that would be B minus x. So now we have expressions relating all three sides of the right triangles. Oh, we know a theorem that relates all three sides of the right triangles. It's called the Pythagorean theorem. So if we take these triangles and we work with our Pythagorean theorem, so for our first triangle, x squared plus h squared equals a squared. So I'm just going to write that out. X squared plus h squared equals a squared. And then for the other triangle, b minus x squared plus h squared equals c squared. Oops, put the square on the inside, but I want that to be outside the parentheses. So we have these two equations. And what we want is we want to find out h. Well, there's no way to find h with what we have because we have two unknowns. But we can expand this, b minus x squared. And remember, expanding binomial to a second power, it is not just b squared minus x squared. It is b squared minus 2bx plus x squared plus h squared equals c squared. Wait a minute. X squared plus h squared. That looks familiar. X squared plus h squared equals a squared. So I could get rid of that. B squared minus 2bx plus a squared equals c squared. And now we have an equation with only one thing that we don't know. This first equation had two things we don't know. The second one had two things we don't know. But this one, the only thing we don't know is x because we know the three side lengths. So we can isolate that x. Subtract a squared, subtract b squared, and divide by negative 2b. So negative 2bx equals negative a squared minus b squared plus c squared. And then divide by negative 2b. And divide by a negative would change all the signs, so it's a squared plus b squared minus c squared all over 2b. So we have x. So we have an expression for x in terms of all the things we know. Well, we don't want x. In our triangle, we want h. We want to be able to find the height, so we can do 1/2 times b times h. Oh, but look here. We have an equation in terms of x and h and a. We know a. And now we know x in terms of a, b, and c. So h squared equals a squared minus x squared. So if we take this and stick it in there, we'll have an expression for h in terms of only a, b, and c, which is what we want. So I'm going to do that on another whiteboard. We have h squared equals a squared minus a squared plus b squared minus c squared all over 2b squared. Oh, that's a beautiful expression, but not be a great thing to plug in. It's not a great formula. There's no real flow to it. So if we could simplify it further, and plus we also have to take the square root. If we could simplify it further, it'd be a lot better for us. So if we look, oh, that's a squared minus that expression squared. Hey, a difference of squares. So if we factor using the difference of squares, that's less powers that we have to deal with. So h squared equals a plus a squared plus b squared minus c squared over 2b. And then a minus a squared plus b squared minus c squared over 2b. Oh, now it's just a sum and a difference. We can simplify a sum and a difference. You need a common denominator, so common denominator would be 2b. So h squared equals. And so you multiply that by 2b. So you get 2ab plus a squared plus b squared minus c squared when you combine your fractions. And this time it'll be the same 2ab minus a squared minus b squared plus c squared, because remember you have to distribute that subtraction, over 2b. So now we have these two fractions being multiplied together. Now I'm not going to distribute through. That's going to get a little more messy too. But let's see if we can recognize some patterns. I'm going to use the commutative property to help us here. So I'm going to swap these first two. So a squared plus 2ab plus b squared minus c squared all over 2b. I'm going to do the same thing in the other one. So negative a squared plus 2ab minus b squared plus c squared all over 2b. Oh, well, what do we have here? If we look at this and we look at this, we have a couple quadratic trinomials that might give us something, that might help us along. So I'm going to take those two quadratic trinomials and just work with them on a different slide or whiteboard, whatever. So a squared plus 2ab plus b squared, that was our first one. Oh, that's just the expansion of a sum of a square of a sum. That's just a plus b squared. And then the other one was negative a squared plus 2ab minus b squared. Well, we like to have a leading coefficient that's positive, so let's factor out that negative one. So negative a squared minus 2ab plus b squared. Oh, look at that inside. That's just the expansion of a square of a difference. So it's negative a minus b squared. So we can replace those with a plus b squared and negative a minus b squared. Gonna need some more room. So now what we have is we have h squared equals a plus b squared minus c squared over 2b. And then it was negative a minus b squared plus c squared. But if we switch those around, c squared minus a minus b squared over 2b, we have that. Wait a minute. That's a difference of 2 squares. A difference of 2 squares we can keep factoring. H squared equals. So it's a plus b minus c. And then a plus b plus c. All over 2b. And that's c minus a minus b, so distribute the negative, minus a plus b. And then c plus a minus b, all over 2b. Oh man, no more powers at all. This is fantastic. Got so excited that I bumped into my tripod. All right. Whew. This is the point where we come back to this. Now, perimeter is the sum of the 3 sides. We're going to have to bring in a new term. It's called semi-perimeter. And we're going to use a variable s. And the semi-perimeter is just like it sounds. When you see this prefix semi, that means this is half of that. A semicircle is half the circle. Semi-annually means it happens twice a year. It compounds at the half-year point. So it's a plus b plus c over 2. In other words, 2s equals a plus b plus c. All right? This is going to be very useful to us. So we have most of the 2s here. We have the entire 2s here. We have most of the 2s and most of the 2s. So with the a plus b plus c, we're missing with the a plus b minus c, we're missing the extra c. This one we have everything. We're missing the a in this one, and this one we're missing the b. Now at this point, I hope you can bear with me. I'm just going to multiply these 2 fractions together. So the product is just going to be the string of these things and of the numerator, and the denominator's product will just be 4b squared. So everything's just going to be over 4b squared. All right, so this one is just 2s. That's just 2s. This one's almost 2s. It's a plus b, but it's missing the c. But do you think you could just add a c? No, that's crazy talk. You can't just pull a number out of nowhere. So in order to balance that out, you need to subtract another c. If you have minus c, that's minus 2c. So it's a plus b plus c minus 2c is the same as that, because c minus 2c gives us that same minus c. And we could do the same thing here. We have a b and c, so it's missing the a, and then minus 2a. A minus 2a gives us that same negative a. And then we have the a and the c. It's missing the b. Oops, plus b, c, minus 2b. B minus 2b gives us that same negative b. So we haven't changed the value of anything. We've just rewritten it. And now we can simplify. A plus b plus c is 2s, so we have 2s from before. Now we have 2s minus 2c, 2s minus 2a, 2s minus 2b. I'm just going to put them in alphabetical order, just for fun. All right. So, wait a minute. There's a 2 here. We could factor out 2 from there, could factor out 2 from there, could factor out 2 from there. So if we factor out the 2 from here, 2 from here, 2 from here, with that 2, that's 4 2's total. 2 to the 4th is 16. But 16 divided by 4 is just 4. So h squared equals 4s times s minus a times s minus b times s minus c all over b squared. All right, so that's h squared. So wouldn't h just be the square root of that? Yeah. So h is the square root of this. So h is equal to, the square root of 4 is 2, so I could just pull out the 2. But the s minus a, s minus b, and s minus c are still stuck inside. They're not perfect squares. And the denominator was b squared. Square root of b squared is just b. Well, our area formula was 1/2 b times h. So if we just plug in, instead of h, we do 2 root s minus a, s minus b, s minus c, all over b. No way. Look at that. 1/2 times 2, those multiply to 1. B divided by b, those divide off to 1. So we're left with Heron's formula. Area of a triangle is the square root of the semiperimeter times the semiperimeter minus one side times the semiperimeter minus the second side times the semiperimeter minus the third side. This is Heron's formula. So if you need to find the area of a triangle and all you know are the 3 sides, you can find the exact area of the triangle. All right. Again, one of my favorite formulas. It's a good time. Have fun.